Okay, so when we play our memory game, right now we've got it set up so that we have labels and we've got the back of cards, but we're going to need something to hold information as we go along. So right now, these are actually just images. These aren't really truly card objects that have values. So I need to have some kind of collection that can hold all of my cards. So if I go into, let me just update here. I always keep forgetting to do my GitHub commits. I did controller. There we go. Put a nice little commit message that we can work with. Okay, so I was saying we need to have something to hold our cards. So in our memory game controller class, we have these variables here, these globally accessible variables to access our different visual elements. So I'm going to add in a couple more here. So I'm going to say private, and I'll have an array list of memory card objects. And these will be the cards in game. Okay, so if you were to play the memory game on your table, you would place cards on the table. You can sort of think of this as equivalent to the table. It's going to hold the cards for us that are in the game. And then our score information here. So like how many guesses we've made, we need something to track that. So I'm going to say int, private int, and we'll say num of guesses, and we'll say num of correct guesses, or maybe number of matches. That's maybe better. Okay. So when a game starts, I need to basically get a deck of cards and then deal myself memory card objects to start the game. And if someone pushes the play again button, then I want to, re-deal the deck and shuffle it and do all these things. So what I'm going to do here is my initialize method, we'll call play again automatically the first time through. And I don't need this action event, so I'm going to get rid of that. System automatically generates it. What we need here is a deck of cards. And then we're going to shuffle the deck, right? And hopefully you're starting to see we chose, method names that really describe what we're doing. So this reads pretty easy, right? It's like get a new deck of cards, shuffle the deck, and then we're going to deal 5 cards, or however many cards are in our image view. So let's set that up. So we're going to say for int I equals 0, I is less than the flow pane, children's size divided by 2. And if you're wondering why divided by 2, so that's going to return 10. Okay, so we're going to have 10 cards. But there's only really 5 unique cards, right? Because 2 of them, for every card, we're going to duplicate it so that we have a match automatically. So let's get that working here. So I'm going to say card delt equals deck deal top card. Okay. And then my array list called cards in game. I'll initialize a new array list for them. So if we have a new game, we need a new, it's like clearing off the table, and we're going to have space to put cards again. And then I'm going to say cards in game, add, and it's expecting a memory card. Okay, so our deck of cards just gives us a regular card. So in here, I'm going to say new memory card, and it needs a suit and a face name. So I'll say card dealt, get the suit, card dealt, get the face name. Right, so now I have a new memory card object, and I'm just going to duplicate that. So I now have two cards, two memory cards in the system. Right, so that's why we had to divide it by 2, because I'm duplicating it here. So now that we have our cards, if we just look at this in the system, I'll just print it out. Cards in game. So let's hit play here. And you can see what we get is, 9 of spades, 8 of hearts, but they're pretty predictable pattern, right? They're one after the other. That wouldn't be a very interesting memory game because you always know the card to the right is the duplicate. So what we're going to do is we'll use the collections class to shuffle the cards. And now when we run it, we should see that we'll have random cards, and now they're also in a random order. So 6 of diamonds and 7, ace. These two happen to be back to back. That's just pure fluke. So that part's working for us now. So we can get rid of that. Okay. So what we want to do is now when we click on a card, we want to be able to flip it over, right? So each of these image views, we gave them a number. And here we have this collection where we also have a number. So if we look at this, in index position 0 of our cards in game, right? Whatever card is in position 0 here, when I flip it over, that didn't update very well, will be in position 0 in my flow pane. Whatever's in position 1 will be in position 1 of my flow pane. So we've got two collections here, right? And basically these are the cards that are in the game, and I want to show them in the image view if the user clicks on them. So let's go into our game here. So in our click listener, last time we just printed out the number for that card, right? So what if now we we just do we flip that card. So I'm going to create a method here called flip card, and we're going to pass in the index position. So I'm going to say image view, get user data. Now the reason I'm doing this again as a separate method is it's just going to make it read a little bit easier, right? So when the mouse is clicked, flip the card. So let's go down here, and we're going to say private void flip card, and in here we're going to expect an integer, and that's the index of the card. Now when I hover over this, I get this error, and it says required type is an integer, and what was provided was an object. And that's because up here, this set user data method, if I just take this over again, if I go set user data, you see the input here is a generic object. So it doesn't know that that's an integer. It doesn't care either. It just knows that it's an object, and everything is an object. Now, in our case, we know it's an integer because we set it. So what we can do is, again, we can cast it to say this is going to be an integer when we say get user data. So if we come down here, now we can start to build the logic for this. And I'm going to do this in a few steps. But first, how do we flip a card? So if I know the index, I can ask my flow pane, give me the children. So this gives me all of the, I'll do it this way, image view. And then I can say get, and it's going to be the index of the card. So again, if we go back to our view, the flow pane holds all of these image view objects. So when I say get children, now I have a collection of all of the image views. And then when I say get, whatever index position it is, 0, 1, 2, 3, it will return me the image view object. So now I can say image view, set the image, and now I have to pass in an image. I know the index of the card, so if I ask the cards in game to get the card, so now I've got the card object, so I can ask the card object for its image. Stop and rerun here. So now when I click on these, they'll turn over. Now, I don't have any logic in here to make them stop turning over, so the game's not too exciting yet. And there's no connection to our labels, but we're getting there, right? We're slowly adding functionality. So what do I want to do? I want to click 2 cards. And if the 2 cards are the same, I want them to be matched. If they're not the same, when I go to click a 3rd card, I want them to flip back over. So let's update our labels here as well as we do this. So we need the idea of tracking the 2 cards that are currently flipped. So I'm going to go up to the top here. And where we have these variables to track the cards that are in the game and our guesses, I can say private memory card. I'll call it card 1 and card 2. And when we go to play again, we need to initialize these to be null. So I'm going to say card 1 equals null, card 2 equals null. So now we can add some logic here. So I'll scroll back down to my flip card area here, and I can test. I can say if first card is null, so this is the first, oh, sorry, I called it card 1. Maybe first card's a better name though. So a neat little trick in a lot of the JetBrains products. JetBrains is the company that makes, they make IntelliJ, PHP Storm, they do Android Studio. But if I want to change this variable name, if I hold Shift and then I hit F6, it brings up this little option here. And if I say first card, you see how it changed it in all the places throughout my program. So I can do the same thing here. If I select this and I do Shift F6, oh, maybe I have to enter. There we go. Shift F6 and second card. Whoops. Second card. There we go. Okay. That didn't work out well at all. All right. So try that again. So if the first card equals null, that's the first card that I'm clicking. So I can say first card equals cards in game, get the index of the card, right? So that's like looking on the table and finding, is it card number 3? And then I can update that image view. But now I can say first card. Okay, so if that was the first card, great. And then I can test else if the second card is null. Okay, so this is the scenario where the first card's selected, but the second card isn't. That's when my guesses should go up, right? Because you're really only guessing when you've selected 2 cards. So I'll say guesses. We've got number of guesses plus plus. And then we can do the same type of thing. And in fact, maybe what I'll do is I'll put that up here, so I don't have to keep typing that same line of code. And I'll say image view, set the image to be the second card. Okay. So in that scenario, we've now updated the image and we've updated the guesses. We haven't updated the label yet. And this is where we would check for a match, right? So if we've got 2 cards, we can say check for a match. And I kind of like doing this as a separate method because, again, the logic of checking for a match is different than the logic for flipping a card over. So I'll go down here, get some fresh space. So I can't do if first card equals second card in this case because of the way I built the cards. So up here, where I said add a new memory card, whenever you use that keyword new, it's going to choose a new spot in memory. So technically, these are different card objects. So I can't just compare if they're exactly equal. So what I can do, though, is I can say if first card is same card as the second card. Okay, so if that's true, we have a match. So our correct guesses, didn't I have, what did I call the correct guesses? Number of matches. Okay, I guess same idea. So number of matches plus plus, because now we have a match. And I can say first card set matched to be true. And I can do the same for the second card. Now, whether or not there's a match, both the first card and second card now should become null because they're either a match or they're both no longer required, right? So I'm going to say first card equals null and second card equals null. Okay, so that handles our scenario. Okay, so let's hit play and see what we get. I don't think we're quite there yet. So I flip it, they're not a match, but I don't flip these back. So I need this idea of checking to flip all of the cards over. So what I'm going to do here is in the flip card method, if the first card is null and the second card is null, then what I want to do is flip all cards. right? So I want to create another method now that will go through and flip all the cards that are not matched. So we can do that right here. So private void flip all cards. And we can say, so if we loop over all of our cards, so I'm going to say for I is less than our cards in the game size. And we can just do a simple little check. If cards in game get I, right? So we're looking through the cards on the table, and we can say is matched. Okay, so if they're matched, then we want to show the front image. So I'll say, I want to do this. Okay, so this gives me access to the image view, right? We've used this a few times. So if the cards in game, if the particular card is matched, so if this card was matched, currently it's obviously not, let's say they were a match, these would be labeled as matched. So I would say to the image view, set the image to be cards in game get I get image. And maybe it's going to be a little cleaner here if we say memory card equals. See if it's doing a lot of typing. So now we can just say if the card is matched, then give its regular image, else set the image to be card get backup card image. So what this will do is it goes over every card after we reset both cards, and it should clean that up for us. So let's hit play now. So happened to be a match, so they should stay up. They did. Also a match. No, not a match, sorry. And they flipped. Okay, so that part's good. So ace, ace. So now it's working as expected in terms of flipping the cards. We need to update this label now. So that label, both these labels, should be updated whenever we flipped two cards. So we've updated the number of guesses at this point. So we can also say update the labels. So here we can say the correct guesses label, set the text, and it's going to be, what do we call it? Num of matches. Now the problem here is this is expecting a string, and what we've given it is an integer. So we just need to convert the integer to a string, and there's a nice little wrapper class called integer that will convert it to a string. And then what was the other label we had? The guess label, set the text. And we do the same type of thing here. So integer to string and num of guesses. So now when we play, it should update our guesses. So it didn't update anything here because we only flipped one card. We flipped two cards. So that's, that's kind of like one guess. but they weren't a match, so the correct stayed at 0. They were a match, so correct goes up to 1. And there we go. Not bad. 7 guesses to get 5 correct ones. So there you have it. That's a pretty simple memory game in Java. And the way we designed it, if the client comes back and says, you know what, I want to do it with 12 cards, it's as easy as going into here and duplicate a couple more cards. Whoops. And we're just going to need to shrink those cards. And you could do this programmatically as well. Let's try, will 150 fit? 125. There we go, that'll fit. But it should now work just the same. Sometimes when you update the view, it caches it in the build. So I'm going to hit rebuild here. So now we should see there's our 12 cards, and it should work the same. Queen of diamonds. How good's my memory? Not that good. There we go. So again, it's a good design because you can easily modify it. We could put in some radio buttons across the bottom here to, easy, medium, and hard, and it would just change the size of these image views, and the program's going to play the same. And if we hit play again, oh, we don't have that wired up yet. I guess that's the one thing we've got left. Let's see here. So when we hit play again, right now, it doesn't, we create a new deck and we do a lot of things, but we don't actually flip the cards back over. So what we can do is we can say flip all cards and hit play. Let's see if that'll solve our problem. Whoops, nope. I did it at the wrong spot. Let's come down here after we have some cards in the game and flip all the cards. This should do it. Okay, so now if I hit play again, it resets them all and we get a new game. So there you have it. I hope you enjoyed the little video series. Cheers.